Hello, everyone. Come to us and ask all the questions that people need to know. In the heart of our universe, where the fabric of reality is stretched by gravity's relentless grip, a strange possibility lurks. A cosmic entity so unfathomable, so extreme, it could challenge the very reign of black holes. Imagine objects whose existence would rewrite our deepest laws of physics. Gravastars, cosmic soap bubbles shimmering with raw primordial energy, bound by a shell fashioned from the most bizarre and indestructible material ever conceived by nature. To grapple with their meaning, we must journey to the thresholds of creation and destruction, where stars meet their fiery ends and new cosmic mysteries are born. When a massive star nears the end of its life, the drama unfolds in an epic supernova. In less than a second, the star's core collapses, squeezed by gravity into densities beyond comprehension. The outer layers surge inward, colliding with the rapidly shrinking core in a cataclysmic rebound. The ensuing detonation rivals the radiance of entire galaxies, briefly illuminating the cosmos as the star dies. But what follows this stellar death throe depends on the star's mass. For many, the core compresses into a neutron star, a hyperdense remnant, so compact that a mere teaspoon weighs more than Everest. Yet, for the most massive stars, the collapse becomes total. Gravity overwhelms all resistance. Matter is crushed into a single point of infinite density, the infamous singularity at the heart of a black hole, a realm where our understanding of reality breaks down and space and time themselves are twisted beyond recognition. But Gravastars suggest a third, even stranger destiny. Instead of collapsing to a singularity, picture the star's core ground away by pressures so intense that atoms, protons, and even subatomic particles are pulverized into pure energy. A bubble of vacuum energy is born. Think of it as a mini-universe unto itself, pressing outward with furious intent. As this energy bubble expands, it smashes into the infalling layers of the dying star. The matter between these opposing cosmic titans is forged into a new form, the likes of which the universe has never seen. An ultra-dense, ultra-cold shell, the boundary between opposites, the casket for a gravastar. So what might a gravastar look like? Stripped of all metaphor, a typical gravastar could be as wide as a sprawling metropolis and weigh as much as 10 suns. Its shell is almost unimaginably thin, yet so perfectly cold that it approaches absolute zero, a billionth of a degree above it, colder than the void between galaxies. Not only does it refuse to emit the smallest whisper of heat, but even the faint glow of relic radiation from the Big Bang, the cosmic microwave background, would seem warm and vibrant by comparison. How could anything be so cold, when all matter is meant to jitter and dance with thermal energy? The answer lies in the strange constitution of the Gravastar's shell. It is not made of atoms. Indeed, to an atom, this shell would seem impossibly thin and impenetrable. Here is matter at the extreme edge of what's possible, forged from the collision of irresistible expansion and inescapable collapse. Stretch this shell by even a single meter, and you would need the energy of a supernova, an energy release that dwarfs anything humanity could ever harness. Peering inside, the Gravastar becomes even more enigmatic. Its interior is not filled with matter or even familiar forms of energy, but with a super-dense form of vacuum itself. A void so tightly packed with latent energy that it represents the ultimate concentration of nothingness. To grasp this, consider our best models of the quantum world. Particles and fields are waves in the vast ocean of the vacuum, an omnipresent background that underpins all of existence. Even when empty of all particles, this quantum vacuum is brimming with potential energy. In the normal stretches of space, even those inside your own body or the air around you, this vacuum energy is present but diffuse, nearly undetectable. Yet within the shell of a gravastar, the vacuum is compressed to its absolute limit. A trillion times more energetic than the feeble vacuum outside. No matter or light may exist here, just this tightly packed, almost metaphysical essence. And though this nothingness strains with untold energy to expand, it is forever trapped by the ultimate shell, the immutable boundary forged from colliding extremes. Here then is a cosmic stalemate. The core cannot expand despite its unease, and the shell cannot be stretched despite being forged to its very limit. In this configuration, the Gravastar achieves an equilibrium, neither collapsing into a dimensionless singularity nor dissipating into ordinary space. From afar, Gravastars would appear nearly indistinguishable from black holes. They bend space and time in the same bewildering ways. They are as dark as anything in the night, as massive as their collapsed cousins, and surrounded by swirling disks of matter and light, warped and contorted by their fierce gravity. For anything foolish enough to venture too close, the outcome is the same. Spaghettification by tidal forces and obliteration against the shell, your matter converted into the energy of the Gravastar's core, enlarging it by an infinitesimal degree. Why should we care about such a wild hypothesis? Reflect on the history of black holes. Once, they too were dismissed as mere mathematical phantoms, relics of theory without physical reality. Yet decade by decade, evidence accumulated. Stars whipped around invisible companions, light distorted by unseen monsters, and eventually, the breathtaking images of glowing accretion disks eclipsed by inky voids. Black holes, once the fever dream of theorists, are now considered cosmic fact. But black holes challenge us with paradoxes. Their singularities defy physics. Their event horizons seem to erase information in ways the universe forbids. Gravastars, by contrast, offer a possible escape. Without singularities, without information loss, they might resolve some of the deepest puzzles in physics. Yet in doing so, they raise new mysteries. What kind of exotic matter could make up that shell? How can the vacuum itself be so compressed? Is such an object stable? As with all great scientific debates, observation holds the key. Black holes possess event horizons, silent, one-way boundaries from which nothing escapes. Gravastars, with their physical shell, should react differently when they merge or collide. Astronomers now listen to the universe for gravitational waves, the tremors of space-time sent out by cosmic cataclysms. A black hole collision rings the cosmos like a drum, fading quickly. A Gravastar collision, so the theory goes, would echo more like a gong, lingering and resonant, marked by faint yet measurable ripples. These signals, should they exist, are buried deep within cosmic noise, and our detectors are only just beginning to reach the required sensitivity. Perhaps in the near future, as technology and understanding advance, we will decipher the true nature of these extreme objects. Whether Gravastars are fleeting fancy or harbingers of a new vision of the cosmos, their possibility reminds us of the ever-changing boundaries of scientific knowledge. By imagining what could be, we challenge ourselves to look, to question, and to discover what is. In this grand pursuit, the universe may once again prove to be far stranger than we could ever dream. And that journey, fueled by curiosity and ever-deepening understanding, is at the heart of all science. As we peer into the darkness, we inch closer to knowing the true shape of reality, forever pushing the limits of what can be understood.